tape this. I'm going to record this. Okay. Let's go to that practice question again. Have you, so the graph has a hole. So instead of being a rational function with a visible vertical asymptote, it has a hole. Why? Let's factorize the function. The numerator, it can be written as x squared minus 1 squared all over x minus 1. Therefore, the numerator is the difference of two squares. So we can rewrite the numerator as x minus 1, x plus 1, all divided by x minus 1. Is there any common factor between numerator and denominator? Yes. Hello, are you looking? Yes. This is important. This is important. So you will not only say that there is a vertical asymptote, you will show there is a common factor between the numerator and denominator. That is why the rational function that is supposed to have a vertical asymptote is now a straight line. But if I find the vertical asymptote, it is x equal to 1. X equal to 1 is the hole in the graph. So instead of saying there's a vertical asymptote, a smarter student will say there's a hole in the graph at x equal to 1. Is that clear? Actually, if you write there's a hole in the graph, my lab maths will mark it and give you 10 points. If you write there is a vertical asymptote as x equal to 1, you get partial credit. Is that clear? You get partial credit because you did not go further to factor the numerator and denominator and see if there is any common factor between them. Is that clear? The zero of that common factor is the hole in the graph. So our conclusion is when there is a rational function and the factors of numerator and denominator has one common factor or even two common factors, then if there are two common factors, there'll be two holes in the graph. If there's one common factor, there'll be one hole in the graph. Instead of now having one vertical asymptote, the vertical asymptote degenerates to a hole in the graph. Does it make sense? Does it make sense, everybody? Okay. Now, this time, let's go to horizontal asymptote. And I'm going to just go to do something on the main board. So I'm going to the main board. And I'm going to get a clean page. We're still on section 6.5. And I already told you what is in 6.6. The only thing is in 6.6 is being able to solve rational inequality. So we will quickly go there. If we can go there, no problem, we can go there on Friday because we still have Monday to review. So now, be careful, this is horizontal asymptote, HA. This is slant asymptote, SL, slant asymptote. So if a function has horizontal asymptote, let me write a function. Suppose this function f of x, oops, go back. F of x, suppose f of x is equal to 1 over x minus 1. All right. What is the degree of numerator? What is the degree of the numerator of that function? Degree of numerator is 1. You know, the degree of numerator is 0. Do you know that? X power 0 is 1. So degree of the numerator, dn is 0. degree of the denominator is 1 x to the power 1, right? So the degree of numerator is smaller by 1. Another way of saying degree of the denominator is 1 greater than degree of the numerator. Therefore, there is a horizontal asymptote. Yes. Function, come on, has horizontal asymptote. So I'm answering the question when. When do we have horizontal asymptote? There could be so many times. I can say A, when the degree of the denominator is greater than the degree of numerator by 1, you have a horizontal asymptote. And that horizontal asymptote is going to be y equal to, come on, that horizontal asymptote will be y equal to 0. There is a horizontal asymptote, and the horizontal asymptote is x equal to 0, y equal to 0. And there is a vertical asymptote in this one. We already talked about vertical asymptote. What is the vertical asymptote in that? What is the see? There's a horizontal asymptote. The horizontal asymptote is y equal to 0 because the degree of the numerator is greater than degree of the denominator is greater by 1 than the degree of the numerator. There is a horizontal asymptote, and that horizontal asymptote is y equal to 0. That horizontal asymptote is y equal to 0. There is also a vertical asymptote. By me looking at the graph, if I equate the denominator to 0 and solve it, y is equal to 1 is a vertical asymptote. Do you agree? Okay. Okay. There is another situation where a function has horizontal asymptote. That situation is, let me say it again. Let's go B. A function has horizontal asymptote. You can do all you're doing today. We're doing this. You know why I'm summarizing this before we find where it is. B. A function can have a horizontal asymptote when the degree of numerator and that of denominator are equal. If the degree of numerator and denominator are equal, there is a horizontal asymptote. How do I find it? Suppose I have 2x plus 1 over x minus 3. Do you see that the degree of numerator and denominator are equal? Yes. So there is a horizontal asymptote. HA, yes. Two situations when there's a horizontal asymptote. When the degree of numerator and denominator are equal, or when the degree of a numerator is less than that of the denominator by 1. Horizontal asymptote. And how do I actually find it? I can just find because I see that this degree and this are equal, I don't even need to do anything. The horizontal asymptote is the coefficient of numerator divided by the coefficient of denominator. That is the horizontal asymptote, y equal to 2. The horizontal asymptote is y equal to 2. I already said how I can find it. How do I find it? I find the coefficient of the highest degree in the numerator and divide it by the coefficient of the highest degree in the denominator. And that is 2 over 1 here, right? Therefore, there is a horizontal asymptote. And it's y equal to 2. Right here, when the numerator's degree is 1 less, you always have horizontal asymptote equal to 0. We talked about horizontal asymptote. That's the way I have already explained it, and very soon I get a question. See if you understand. I'm going to get a question, see if you understand. Okay, let's talk about slant asymptote. That way we can look at a rational function. A rational function can have all three of them. It can have a vertical asymptote or 2 vertical asymptotes. It can have a horizontal asymptote. It can also have a slant asymptote. It can have both of them. Excuse me, all three of them. Excuse me. Okay, we talked about horizontal asymptote. It could happen in 2 ways. And I'm recording this. It's also in the video, ebook video. Okay, I'm going to move this out, and let's talk about slant asymptote. Slant asymptote. Asymptote. And this kind of asymptote can look like this. Suppose I have a graph here, and I can have and I can have one going this way, something like this. And the slant asymptote can be a broken line drawn like this. A slant asymptote is a line, an oblique line. And you can also have a vertical asymptote. This function, this unnamed function, can have a vertical asymptote. It can have a slant asymptote. Okay, so when do we have a slant asymptote? I'm going to write a question. So let me just write make up a question. I'm making it up so that we can look at an actual question. So let's just let me just write a question. 2x, or just let me not use 2. I'm going to use just x. So I'm going to make up a question. X squared plus 1 divided by x minus 1. I wanted to see this function. We haven't had a situation when the degree of the numerator is greater than the degree of the denominator. So whenever the degree of numerator is greater than the degree of denominator by 1, there is a slant asymptote. Whenever, I'm going to hammer it out. I don't care if I'm shouting. I just want to make sure that maybe in 4 years you're still going to remember, oh, she shouted, because I don't shout. If you don't shout and you shout one time, people say, what's wrong with this guy? This is going crazy. You see, it's going to be one time when the degree of numerator is greater than the degree of the denominator by 1. That's a slant asymptote, and you have to find it. You got to find it by division. Let me give you time to marinate that. Okay. And then how do I find it by division? You already know how to divide. I already know. See, if I add all the function, I already know there's a slant asymptote. Why? Because see, even if just knowing that is even enough for some professors. They just know that that is important. Oh, okay, okay, the function has a slant asymptote. Because why? Because the degree of numerator is greater than degree of denominator by 1. Okay, so what happens? Suppose I have x cubed plus 1 over x minus 1. Does it have a slant asymptote? No, because the degree is greater by 2. No asymptote. No slant asymptote. No slant asymptote. The only time you have a slant asymptote is when the degree is greater by 1. When it is greater by 2, 3, 4, 20, that's not a slant asymptote. I'm going to give you time again. I'm going to give you time again to marinate that. So you can eyeball a rational function and describe it. You can eyeball, first of all, you already know that this function has a vertical asymptote, right? And if a function has a slant asymptote, it doesn't have a horizontal asymptote. If the function has a slant asymptote, you don't have a horizontal asymptote. Is that clear? I didn't say this last class because I know if I had said all this in one class, it's going to be confusing. I don't want students who get to calculus 2 and then you're given this function, they cannot describe it. Okay, not to talk about finding the first derivative, second derivative, and adding the derivative functions. Do you know? If you don't know the beginning, how would you know? How would you come and you don't know the beginning? When would you start applying the steps? How would you apply the steps, but you don't even know the beginning? Okay, let me find the horizontal asymptote. Okay. Okay, it's not about looking at the answer. I know that this practice test has answers. So the first thing I want to ask is, 1, does it have a horizontal asymptote? You can answer this question now. Does this have a horizontal asymptote? Yes. Is it yes? Is your answer yes? What is it? What is the equation of the horizontal asymptote? Exactly. Why? Why do you say that the horizontal asymptote is y equal to 0? Because the degree of the numerator is less than the degree of the denominator by 1, or the other way around, degree of denominator is greater by 1. So there is a horizontal asymptote, and the horizontal asymptote is y equal to 0. So HA is present and it is 1, and y equal to 0. Does it have a vertical asymptote? VA. Does it have a vertical asymptote or 2? Yes. So you want to write 9x divided, equate the denominator to 0. So you have x minus 6x plus 6. That's the difference of 2 squares equal to 0, right? Factors are plus or minus 6. And so the vertical asymptotes are minus 6 and plus 6. So there are 2 vertical asymptotes. So vertical asymptote is present. All right. If it has a horizontal asymptote, does it have a slant asymptote? No. So you have answered the question. So I just want to let you know that you don't even need to do a lot. You just have to eyeball it. Eyeball it. And if you paid attention to what I said, you see that you actually know it. So did I clear the air about vertical asymptote, horizontal asymptote, and slant asymptote? Trust me, if you can eyeball the function and know the reason why there is a vertical asymptote, the reason why there's a horizontal asymptote, and the reason why there's a vertical asymptote, you have gone 90% of the way. The only 10% is finding the slant asymptote when it exists, and you do it by division. And actually, you do it by division. What time do we have? We still have time, so don't take your bag yet. We have time, so we can. So let me see what we can do. I don't intend to do, because I picked the questions for you, so I don't intend to do all of them. I just want to. I'm going to. I want to make sure that I emphasize the salient points. Find the equation of any vertical asymptote. Do we have any in number 10? What is it? Look at it. Don't solve it. Look, eyeball that question. Do we have a vertical asymptote in number 10? Yes, we do. What is it? What is it? Somebody raise your hand. Say it. I don't have time to waste. I mean, this is a test you will write for me. So if you don't want to say anything, we can continue. What is the vertical asymptote? X equal to 2. So we continue. Vertical asymptote is x equal to 2. Does it have a horizontal asymptote? Does it have horizontal asymptote? No. It does not have a horizontal asymptote because the degree of numerator is greater than the degree of denominator. No horizontal asymptote. Does it have a slant asymptote? Yes, because the degree of numerator is greater by 1. That is when there's a slant asymptote. So you already know that. And then we are going to divide. We will divide this one. Do we have time to divide it? Let's quickly divide. So you divide. I know that this division, you might not get it today, so we'll finish the division on Friday, but let's start dividing. Okay, now I know when there's a slant asymptote, degree of numerator is greater by 1. Then how do I get that equation, which is called slant asymptote? It's by division. So there are so many ways you learn division. There's one called synthetic division. Who remembers synthetic division? Raise your hand. You can do a synthetic division, or you can do a long division. And anyone, you better remember it, because I know you did it on 102 or 103, or don't tell me you didn't do it. This synthetic division is not for this class. But how do you find the slant asymptote? You will be told to find it. How do you find it? By either long division or synthetic division. If you're dividing x squared by x, your answer, your quotient better be a linear equation. So find that linear equation that is the vertical asymptote. Let's do the long division quickly. And so we can put in all this. Next time we do the synthetic. Minus 2x plus 5. And let's write the quotient here, x minus 2. And what do I multiply this function by? X to get x squared. X multiply this, x squared minus 2x. Let me subtract. X squared minus 2, x squared, cancel, minus 2x minus 2x, cancel. Okay, so I already, then I have a remainder 5. So actually have the solution. And so this quantity, so this quantity here is equal to x plus 5 over x minus 2. Therefore, the slant asymptote is y equal to x. Only this one. This is the slant asymptote, the equation of the slant asymptote. It's y equal to x. It's as simple as that. You can do a long division or synthetic division, whichever one you want to do. So the remainder is 5 over x minus 2. Any question? It doesn't take a long time. Okay, if you don't have any question, I did the row. Okay, next class we will try and finish. And by the way, Monday will be review then. Test will be Wednesday. Any question from online? Any question from online? Our test will be on Wednesday, so you can. Okay, I'll mark you present. Those of you there.